Morning, guys. Hope everybody had a good weekend. I'm going to start here on Monday. We're going to be looking at plumbing systems in your household with the intent of you adding the plumbing to your Habitat for Humanity design. Albert Einstein was named an honorary member of the Plumbers and Steamfitters Union after publicly stating that he would become a plumber if he had it to do all over again. I don't know that that's the truth. I've never read that anywhere, but according to this PowerPoint, supposedly that's what it is. Some things we're going to go over in here. We're going to go over the Romans, what their part in plumbing was, what water supply systems are, that part of it, although we've gone over quite a bit of it already. Drain, waste, and vent systems, what they're for. Plumbing codes, plumbing plans, which is critical to what you're doing today. And energy conservation. Okay. The table of contents: Romans, water supply system, drain, waste, vent system, plumbing codes, plumbing plans, energy conservation. And when we talk about energy conservation, we're talking equally about the conservation of water, the electricity for pumping it, and the electricity or gas for heating it. The Romans, what's the deal with them? Aqueducts transported water from sources. The highest quality supplied drinking fountains. Lower quality supplied public baths and latrines. Lead pipes, using lead because it was so easy to work with, transferred water to limited users. The Romans were well known for their public water supply and wastewater systems, except for the wealthy, though. Most access points to the system were located outside of buildings. Wastewater systems, chamber pots in residences dumped out the windows. This is where the phrase came from. Didn't have a pot to pee in. These are the pots that they're referring to. I always thought that was an odd phrase my grandparents used growing up. That's where that phrase came from, but they never told me that. Toilets, they were a luxury. A hole in the floor drained to a cesspool below. Public latrines, they were wastewater flowed through central channels into main sewage systems and into nearby rivers and streams to be washed away. Very few private wastewater system connections. Of course, only for the wealthy. Very much like today, the wealthiest get the best of everything in life. Plumbing system. What components consist in a plumbing system? We have water supply pipes, fixtures or a device that uses water, sink, toilets, dishwashers, whatever. Soil, waste, and vent pipes, drain and sewer, the gas pipes, and then the storm water discharge. A plumbing system consists of all of these elements. Often gas and storm water drain pipes are also installed and are considered part of the plumbing system. Here's a three-dimensional view of a water supply system. Note that the yellow arrows point to each component as it is defined. The network of pipes that transport hot and cold potable water under pressure. The top here, we've got the bathtub, the toilet, and the bottom being the washing machine. Fixture, any device that uses water, sink, toilet, dishwasher, etc. Water heater, lower right hand corner here, large insulated tanks that heat cold water to be distributed into the hot water supply lines. These are more oftenly being replaced by an on-demand system, whereas a hot water heater has a tank, it's well insulated, and it heats it, so it is a tank full of water that is kept hot at all times, whether you're using it or not. Whereas an on-demand system has a coil, or let's say it looks like a spring, but instead of solid steel, it's a pipe. So it looks like a spring, and then as you turn the hot water on, the relief and pressure fires it up and causes a fire inside that coil, and it rapidly heats all of that water up. And then when you shut it off, it shuts the flame down, saving and conserving energy. Trunk lines. These are hot or cold water pipes that serve many fixtures. They're the larger ones. Branch lines, they're the smaller ones, hot or cold water pipes that serve only one or two fixtures. Water main, this is the supply line that comes in from the road and maintained by a public entity, the town you live in, the city you live in, whoever you're paying your bills to, and on public property. The main goes to the meter, which counts how much water and records how much water you use. You are responsible on your property for the maintenance, upkeep, and the water lines from the meter to the house. The water service, the pipe from the water main to the building supply pipes. The meter measures the amount of water transported through the water service. A valve is a fitting used to control water flow, located next to the main meter so that you can shut it off should there be a leak or should you need to do maintenance or install new systems. The drain waste vent system. It's designed to safely convey the waste and wastewater from the building while allowing noxious gases, fumes, smells, odors that are created from sewage to escape to the exterior of the building. In the diagram, the drain piping is shown in green and the vent piping is shown in the orange. Okay. A network of pipes to transport this wastewater. Drain pipe, a pipe that carries wastewater inside of a building. The vent pipe is the vertical pipe that provides the circulation of air to and from the drainage system, since it works on gravity. A trap is a fitting, usually U-shaped, that provides a seal to prevent the flow of sewer gases. So if you look at that green or yellow arrow right now, you see the P trap, and it's not for urine. The P is because it's shaped like a P, and that water, there's always a loop of water at the bottom. So right here, where this is gases that go out through the roof, shows that it doesn't become vapor locked. This water laying in this P-trap stops the flow of air back through the toilet or through the any parts of the system, allowing those noxious gases back up into the house. A stack is a vertical pipe, waste or vent, that extends through at least one story. The cleanout is an access opening to allow cleanout of the pipe either out to the septic tank or to the sewer line. Sewage, by definition, is any liquid waste containing animal or vegetable matter, including liquids and containing chemicals. Sanitary sewer, a sewer pipe that carries only sewage, like the ones from your toilet. Storm sewer, that's a sewer pipe that carries storm water or other drainage water, but not sewage. This would be from your shower, from your washing machines, from your sinks. It's your gray water. Building or sewer lateral. That's part of the drainage system from the building to the public, private, or individual sewer disposal system. Sewer main. That's a sewer pipe installed and maintained by the public entity and on public property. Plumbing codes. Like any building codes, are there to protect the health and the safety of the community. They reduce potential for widespread disease, provide rules and regulations for installing drink water or sewer facilities, identifying required methods for installing plumber systems, provide permits and inspections. The International Residential Code includes requirements for residential plumbing systems. International Plumbing Code is a model code that has been widely adopted throughout the United States for non-residential facilities. It also covers the supply size dependent upon the amount of water, the water pressure, pipe length, the number of stories, flow pressure necessary at the farthest point in the system. It also covers drainage and vent pipe size dependent upon the plumbing fixture units and the type of fixture, and as well as the estimated amount of waste. Although the International Plumbing Code provides requirements for all aspects of a building's plumbing system, the IBC International Building Codes incorporates a few of the plumbing regulations, including the minimum number of certain plumbing fixtures also, as well as the location of toilet facilities and the design of the toilet room and partitions. This picture happens to show a row of showers and lavatories in a sports club. So these are all covered by plumbing codes. This plan was created with Revit software, which you guys should be using, but due to the Rona, we are not at this particular time. But we're going to be doing this on paper, so you're going to need either some colored markers or colored pencils or something along those lines. Plumbing plans are used to show the location of the water supply, the vent, and drain lines, but they may also include stormwater drains and gas lines. Note the difference in the line types in the right-hand side legend. Red dashed for hot, cold dash dot for blue, green for drain, and black for vent. Most plans, however, will be in black and white, so the line style is used to differentiate the various types of pipe when you can't see the color. Be sure to record the line style and the color for each pipe. You'll need this information for the next activity that we're going to do. There's isometric plumbing plans, which is a common type of plumbing view. This particular drawing illustrates a drain waste vent system, a DWV. Although not common for residential systems, isometrics are often created for larger commercial facilities due to the complexity of the piping. Note that the toilets often have traps incorporated into their design and therefore do not require an additional trap in the system. Also note that the connections in the sanitary drains are Y-shaped and not T-shaped to facilitate movement of waste better, to hopefully eliminate plugs. Many shower packages such as Revit MEP, which is mechanical, for software packages include electrical and plumbing and can create isometric plumbing drawings. These design tips will provide energy savings when designing a plumbing system. Locating the hot water heater in conditioned spaces, so you don't want the hot water heater outside in an outside shed on the side of the building, obviously, especially in a northern facility. Insulated hot water heater. Insulate exposed hot water pipes. especially up north where you've got water pipes running through basements that are not heated. Insulate cold water pipes with freezing potential. Place water pipes in interior walls if possible, and use low flow fixtures. And seal all wall fenestrations. So the things that we've gone over here. The part that the Romans played in plumbing, water supply systems, drain waste vent systems, plumbing codes, plumbing plans, and water conservation, as well as energy conservation as it pertains to water systems. That's it for this presentation, guys. The instructions for your next activity are written below this on the haiku page, and you're to follow those. Thanks a lot for watching, and I will see you tomorrow morning.